Hey everybody, it's Mrs. Gauthier, and we are doing homework for 613 today. Okay, so we start off with some translations. It says Erin started with one corner of her figure located at -4, 5, and she translated it to end at 6, 8. To find how far her shape moved horizontally, she decided to find the difference between the two x coordinates. So she wrote 6, negative, or opposite -4, minus -4. Any way of those would work. Okay, so where did she get the 6 and the minus -4 from, right? Well, the 6, right, if we look at her point of where it ended at, the 6 is the x value, which if she's moving horizontally, that would be side to side, which is on the x-axis. So we look at the x number in our coordinate. So that's where we got that 6 from. The -4, right, is our original, our starting point, and that is -4. Why are we subtracting? We're finding the difference between the two, so that would mean to subtract. All right, so our equation, right, was 6 minus -4. All right, so when she simplified, her answer was 2. Is she correct? If not, what's the better simplification? Okay, well, I know that the opposite of -4 is +4. So 6 plus, right, it's going to be +4, I know, equals 10. So she was not correct when she said 2 because she didn't simplify it correctly. So no, her shape translated or you could say slid, right? That's like the other term for it. Slid 10 units to the right. And you do have to tell us how many spots they moved and also in what direction. So make sure that you have this whole thing. Don't just write no, or don't just write this equation. You have to have the whole thing. Okay, and we have her new simplified equation right there, so we're good on that one. All right, for letter B then, it says write another expression to find out how far the shape moved vertically, meaning up and down. Simplify the expression and describe the translation. Okay, so for this one, instead of looking at the x values, we're now going to look at these y values right here. So the 8 and the 5, right? So when we subtract these, finding the difference between them, 8 minus 5 equals, we know that would be 3, right? So then when we write it out, it moved technically 10 units, right, still to the right. And because this is +3, and she moved up 3 units. Okay, there we go. All right, so now it says describe each of the translations below. So I did include a coordinate plane here. If you guys want to use it to kind of see what happens, you certainly can. We can go ahead, we could plot this point of 3, 1, 2, 3, -2, meaning down 2, would be right here. And it's going to move to 5, 1, 2, 3, 4, 5, and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't even know, that might be off paper. Yep, it is. Right there. Okay, those are my 2 points. So now I could say, okay, I moved how many to the right? I moved 1, 2 to the right. So up here, right, 2 right. And then that got me here. And then how many down did we have to go? Let's see, 1, 2, 3, 4, 5, 6, 7, right? And 7 down. Okay. The other way that we can look at it, remember, is by subtracting these two. So I take my x value and my x value and I subtract them. And when I do, that's where that 2 comes from. I do the same thing here. The -9, -9 minus the opposite of negative, or minus -2, or the opposite of 2, and then we would get 7. Okay, and that would be, it's -7, so that means that we go down, right? That's the negative piece. Okay, so you can either do it like with the equation, or you can plot the points down here. Either way works. I'll show you both ways just so that you kind of can see both, but do whichever one's easier for you. All right, so our next one is -1 on the x. I'm just going to use a different color here. And then up 4. 1, 2, 3, 4, just so you can kind of keep it all separate. All right, and then 6. 1, 2, 3, 4, 5, 6, and then down to 1, 2, Okay, just like that. So then we could say, this is her original. You also have to make sure that you start with your original. So we moved over, let's see, 1, 2, 3, 4, 5, 6, 7. So right, 7 to the right. And then that got me to here. And then 1, 2, 3, 4, 5, 6 down. 6 down. Okay. Or we could have done 6, we always have to start with our original. -1 minus 6. Or 6 minus, 6 minus -1. There we go. To get 7, because that's like plus the opposite. And then our -2, or 4 minus -2 to get me the -6 to then go down. It's kind of early this morning. I'm like, oh. Okay, new color. First point, 0, 0, right in the middle. That's a nice, easy point to find. And then we have -4, 1, 2, 3, 4, down 7, 1, 2, 3, 4, 5, 6, 7. All right, there are my 2 points. So, starting at my origin here, I did have to move left, so that's going to be negative 1, 2, 3, 4 to the left. And then that got me here, 1, 2, 3, 4, 5, 6 down. So again, that's going to be negative. And just remember too, with our equation here, I could do my -4. Just write it out here. -4 minus 0, right, would give me -4, which is why we're moving left. That would be negative because that's into the negative region. And then the other equation for this one would be -7 minus 0 equals -7, which is why we're going down 7. Oh, I miscounted. I'm like, why is this right? This is 7 down. I just didn't count it correctly. 1 in. Oh yeah, 7. Okay. There we go. Sorry, I messed up when I was counting. Okay. One more to go. I don't know that I have another color. I guess we'll use pencil again. Okay. -2, 1, 2, and then down 9. 9. Okay. Yeah, sometimes it's hard to talk and count and do all of that at the same time. All right, and then we have, okay, so we have that point. Then we have 2, 1, 2, positive 9. Woo, this one moved a lot. 9. Okay. There's that point. Can you see them? Okay. So with this one, they're so far apart, I would for sure use this method instead of counting. I mean, you can count, but I'm going to make my life a little bit easier here. So 2 minus the opposite of 2, looking at both of those x values. And the opposite of -2 I know is positive 2. So 2 plus 2 is 4. So she moved 4 to the right because it's a positive. So 4 right. Yep. And then the 9 minus the opposite of 9, which would be positive 9. 9 plus 9 is 18. So that means that she moved, and it's positive. So 18 up. Okay. Hopefully that makes sense. Alrighty, flipping the page over for our next problem. Okay, so on graph paper, it says set up an x and y axes for the 4-quadrant graph. Then draw a triangle with vertices with these points and label the triangle T. So let's do that first. I'm going to grab some blue here just to get an axis on here. Set of axes. My y. There's my x. Okay, let's graph some points. Plot 1, 1, which would be right there. 5, 1, 1, 2, 3, 4, 5, 1. 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. Sorry, I have to count out loud. Otherwise, when I'm talking, I can't get my shapes counted right, or my figures counted right. All right, so this we said was T. Just stick a T in the middle there. Okay, so there's my first triangle. Oops. I'm going to show it to you. You can label that, right? All right. Next up, for A, it says to translate or slide the triangle left 3 units and down 4. Label this triangle A and list the vertices. So first, let's slide pick one point to start with. I'm going to pick the farthest one to the left. And we're sliding this left 3 units. So 1, 2, 3. Remember, the y-axis counts as one thing to slide to. And then we had to go down 4. 1, 2, 3, 4. So right here. All right, there's my first point. Now I'm going to do this other one, the other bottom one. So I'm going 3 units to the left. 1, 2, 3. And yes, it might still be on one of your other triangles. And down 4. 1, 2, 3, 4. Okay. You'll notice it should kind of match up. See how it made a straight line? Guess what? It's making a straight line right there. If it doesn't look right, then something's probably wrong. Okay. This last point here, we're moving over 3. 1, 2, 3 to the left, down 4. 1, 2, 3, and 4. Okay. We can double check. Yep, it looks like the same shape. If it doesn't, you need to look at it because something is off. All right, this is triangle A. Just like that. Okay, beautiful. Next, reflect triangle T. So this original triangle, we're reflecting across the y-axis. Label it triangle B and list the vertices. Ooh, we forgot the vertices on this one. I got to go back and do that. So where are each of these points at? Well, this first one, let's see, 1, 2, 3. 3, comma, let's see, we went down 1, so -1. 3, -1 for the top. Then for this bottom guy, we went over 2, right, in the positive. And then we came down 1, 2, 3, so -3. And then our last point, we moved left. So 1, 2, that's going to be -2. And how many did we come down? 1, 2, 3. So -3. Okay, there are my points, my vertice points. Okay, so now going back to B, reflecting this over the y-axis. First of all, we need to know that this right here, right, going up and down, this is our y-axis. So we're going to be reflecting, which means flipping it over, right? So it's coming from this side, and we're flipping it over, kind of like a pancake. All right, so we take each point at a time, and we measure how far away from the line of reflection, the y-axis in this case, our point is. So in this case, this first point is just 1 away. So that means instead of going to the right one, I need to go to the left one and put my first point there. I'm going to do the same thing with this next point. How far away is it from my line of reflection or my y-axis? It is 1, 2, 3, 4, 5 away. So I go to my y-axis, and now I'm going to move in the opposite direction 5 units. 1, 2, 3, 4, 5. Put my point right there. All right, last point. 1, 2, 3, 4, 5, 6 away. So 1, 2, 3, 4, 5, 6 away. All right, you'll notice we still have a triangle here. However, it's in a little bit different position. Okay, see how it kind of flipped itself over, right? This point is now the farther point. Okay, and then we need to label this B and then name the vertices. So this is B. Now my new vertice is -1, right? We have to move to the left 1 and then up 1. So -1, 1. This guy over here, 1, 2, 3, 4, 5 on the x. So -5, comma 1, right? +1. Okay. And then this last one, 1, 2, 3, 4, 5, 6, -6, comma, how many did we go up? 1, 2, and 3. -6, 3. Okay. Last bit here, part C. Are triangles T, A, and B congruent? That is, do they have the same shape and the same size? And explain. They have not gotten any larger or any smaller, right? They might have changed their spot on the coordinate plane, but they haven't gotten any larger or smaller. So they are still congruent. So up here we can say yes. Translations and reflections don't affect the shape of the size of the shape. Okay, translations and reflections, even rotations too, they don't either. For future reference, reflections do not change the size or the shape. Meaning, even though these two triangles were flipped, the shape itself didn't change. They just were flipped. Okay. All right. On to the next one. So we have to change the equation into y equals mx plus b form. A little review from last chapter. Okay. Remember, here's our y equals mx plus b form. So we're trying to get the y on one side and all the other stuff onto the other side. So first, we have y minus 4x equals negative 3. I like to rewrite it just so I have some room to do so. So I know in order to get the y by itself, I need to get rid of this negative 4x, right? So I'm going to add positive or add 4x on both sides to make that a 0 pair, essentially, plus 4x over here. So that would leave me with y equals, I like to put the x value first because that's where it falls in the y equals mx plus b form. So 4x minus, right, because this is negative 3 minus 3. There's my y equals mx plus b form. Okay. All right, next one. I'm going to do that one over here just so I give myself plenty of room. 3y minus 3x equals 9. Okay, so I know I need to get this 3x over here first. I am going to have to do some dividing there with the 3, but first I want to take care of this subtracting, getting the x over. So I'm going to add 3x on both sides, right, because this is going to create that 0. Whatever we do to one side, we have to do to the other side. So then 3y equals 3x plus 9, okay? Now, my y's are not completely by themselves yet, right? So I need to divide by this 3 because right now it's being multiplied. So divide by 3, divide by 3. I have to divide everything by 3. So that means y equals 3 divided by 3 is 1, right? So that's just x. I don't have to write the 1, I can just write the x. Now, 3 goes into 9 how many times? It goes in 3 times. So my equation here is y equals x plus 3. Okay, hopefully that guy makes sense. All right, letter, and here, let's just draw a little arrow so I remember which one's which. All right, letter C here. 3x plus 2y equals 12. All right, again, I'm trying to get my y's by themselves, so I'm going to move these x's first. That's always my first move, typically, unless there's like terms I can combine. So minus 3x on both sides. That leaves me with just 2y on the left and negative 3x plus 12 on the right. Okay. Lastly, my y's aren't alone yet, so I'm going to divide by that coefficient in front of my y, leaving me with y equals, now 2 doesn't go into negative 3 nicely, so we're just going to leave that as a fraction. We're just going to say negative 3 halves x. Now 2 does go nicely into 12, right? That would be 6. So we can just take care of that guy. Now there is our new equation. Y equals negative 3 halves x plus 6. All right, one more like it. Letter D, I'm going to do him over here again, just so I have lots of room. All right, minus 3 plus 3y equals 0. Okay, first things first, we know we have to deal with the parentheses, right? All right, distributing to our parentheses, multiplying everything inside the parentheses by what's outside. 2 times x, we know, is 2x. 2 times negative 3 is negative 6. And then the plus 3y does not get multiplied by the 2. It is not inside the parentheses. All right, all of that equals 0. Now, I need to move everything else right over. So I'm going to subtract by 2x first, minus 2x on both sides, which is going to leave me with negative 6 plus 3y equals negative 2x, right? Then I need to get rid of the 6, so it's negative right now, so I'm going to add 6 on both sides, plus 6 plus 6. I'm left with 3y equals negative 2x plus 6. I cannot combine my x's and unit tiles. And lastly, I need to divide by that coefficient in front of the y. So I'm just going to write my equation over here, my new equation. Y equals, now this, again, this fraction is not a nice one, so I'm just going to leave it as negative 2/3 x. And then 3 goes into 6 nicely. That would just be plus 2. So there's my new equation. Y equals negative 2/3 x plus 2. Alrighty, so we have all those ones done and taken care of. Let's look at number 30. It says that we need to solve the problem below by defining a variable and then writing and solving an equation. Okay, so we're given a perimeter of a triangle is 31 centimeters. Perimeter, remember, is like side plus side plus side. So if I have a triangle, it's like this side plus this side plus this side, All of that is 31. Okay, side 1 and side 2 have equal length, while side 3 is 1 centimeter shorter than twice the length of side 1. How long is each side of the triangle? Okay, so again, I'm just going to draw a bigger triangle here so I can label it. All right, I'm just going to say this is side 1, here's side 2, and here's side 3. So side 1, I don't really know much about. All I know is that it has an equal length with side 2. So I'm going to call that, I'm going to make that x, right? Because I don't have a lot of information about him. I probably need to solve for that. Side 2, I also don't have a lot of information about, aside from it's the same length as side 1. So that means it's also going to be x. Now, for side 3, I have some info, right? Let's see. Let's go back. 1 centimeter shorter than twice the length of side 1. So if something is twice the length, I'm multiplying by 2, right? So it's going to be 2 times however much side 1 is. And then it said it was 1 centimeter shorter. So that means I need to subtract 1, right, from that. So there's my variables kind of all set up. And then I know that this whole thing, right, when I add them all together, my perimeter was 31 centimeters. Okay, so that's my whole thing there. All right, so now we need to set up our equation here. We know that perimeter is adding up all the sides. So I'm going to be adding x, right, for my side 1, plus x, okay, plus my side 3, which was 2x minus 1, equals that whole total was 31. Okay, so there's my equation. I'm going to combine my like terms. How many x's do we have? Well, we have 1 here, and then 2 x's here. So we have 4 x's altogether. 4x minus 1 equals 31. All right, I'm solving for x, so I'm going to deal with this unit before I do any dividing. I'm going to add 1 on both sides. So I end with 4x equals 32. And then lastly, I need to divide by that coefficient in front of my variable, which is 4. Divide by 4. And we know that 4 goes into 32 8 times, right? 4 times 8 is 32. So there's my x value. Okay, we are not done yet because we need to double check this. So I'm going to plug this 8 back into my original equation up here and in for x. So that means I have 8 plus 2 times 8 minus 1 equals 31. All right, so we're going to do our multiplication first. That part stays the same. 8 times 2 is 16, minus 1 is 31. Okay, now I can just do all of my adding, right? So 18 plus 8, or 8 plus 8 is 16, plus another 16 minus 1 is 31. I can add these, right, all together, and that's 12. Yep, 31 equals 31. That checks out. Excellent. Okay, now last piece was it asked us how long each side was. So I'm just going to write them over here. Side 1 was just x, and we saw that x was 8, so side 1 has to be 8 centimeters. Side 2 is also going to have to be, right, it was the same length, so 8 centimeters. And side 3 is going to end up being our 2 times 8, right, minus 1. Plugging back into this original equation, 8 in for x, then I have to solve this. So 16 minus 1 is going to be 15 centimeters for side 3. Okay? All right, hopefully those guys all make sense for you. Let's go on and do our last page. I know this one is kind of a long homework assignment, but thanks for bearing with me. All right, number 31, we are simplifying each expression, right? So not too horrible. It should be hopefully mostly review for you. So the first thing I'm going to do is do a little fraction buster just to bust up these guys. So I'm going to multiply everything by my denominators. 100 times 70, or sorry, and negative 7. Yeah, because that's my other denominator. I don't know where I was getting 73. Oh, from my numerator. I have to look at the denominators. And then 100 times negative 7 over here. Cross canceling, right? 100 out, negative 7 out. Then I'm going to multiply. So my negative 7 times my 73 leaves me with negative 511 when I punch that in my calculator. And then I'm going to be multiplying by my 2 times my 100 right here, which is 200. And when I calculate that, right, when I multiply those together, I end up with negative 102,200, just like that. Or if I wanted to leave it as a or it could be 73 over 350, just like that. Alrighty. My next one, I'm just going to punch this one into my calculator. I would say you should probably do that too. So negative 0.4 times negative 0.3. Let's see when I punch that in. 0.12, right? Because 3 times 4, I mean, we could do that too. That's not very hard. All right. For my next guy here, right, we have, I'm going to put these, find like a common denominator between these. So I first need to put them into an fraction larger than 1. I'm going to get rid of the mixed number. Okay. So to do that, remember, we're just multiplying the 5 times 9. So 5 times 9 we know is 45, plus 1 more is 46. So that's my new numerator. My denominator always stays the same. Just hopefully is review from when you were in younger grade. Same thing here. 8 times 5 is 40, plus 2 is 42 over 5. So now, see how I got rid of the mixed numbers? We put them in improper fractions. Okay, so now that we have them like that, I need to find common denominators for them. So I'm going to start with my 46 over 9. And I know that if I multiply these two together, that'll give me a denominator that I can work with, right? So I'm going to take 46 and I'm going to multiply by, in this case, 5. Because I'm going to do 9 times 5 down here. So 9 times 5 to find a common denominator. This we know is going to be 45. And 46 times 5 would be 230. There we go. All right, and then do the same thing with your other fractions. So 42 over 5. We're going to multiply it by 9 this time. So 42 times 9. And 5 times 9. 5 times 9 we know is 45. And then multiplying these guys. Okay, I get 378. All right, now I can go ahead and add these now that they have common denominators, right? If they don't, we cannot add them together. So 230 over 45 plus 378 over 45. Yes, I know these are big numbers, but work with me. When I add those together, let's see, 608 over 45. I can then simplify this, right? Let's simplify that. Or I could write it as a decimal. That would be 13, if I write it as a decimal, 13.51. Or if I want to leave it as a simplified fraction, let's see, I could do 13 would be my mixed number. And then 23 over 45 could work. There we go. So either one of those will work. Excellent. Okay, last one. Woohoo, we're almost there. So we can convert this into a decimal just so that they're both in the same form. And then we can go ahead and add them. Let's see. So I'm going to punch this in my calculator here. So I end up with negative 1 point. Let's see. Oh, for this one, it would be 0.8. So negative 1.8 or negative 1 4/5 would work for my answer there. All right. Next up, we have 32. So each part A through D represents a different tile pattern. For each, we have to find the pattern of growth and the number of tiles in figure 0. All right, so let's start shading in on our tiles. Which tiles are being added? How many of them are there? I can see that for sure I'm adding 2 on each side right here. Okay, and then there's an extra one down on the tail, right? So I'm going to shade those in just like that. Now I can create my rule. Y equals, in this case, my growth, I'm adding how many tiles each time? 2 here, 2 here, and 1 there. 5. X, right? Adding the X on. And then how many tiles would be in figure 0? So I have to work backwards. I have to take 5 off of here. So 1, 2, 3, 4, 5, and then another 5 off. 1, 2, 3, 4, 5. Then I can see all that I have left is going to be this little group of 3 right there. So plus 3 in figure 0. We may have made a table, and if some of you guys are still at that point, go ahead and make a table. That's fine. and then find the growth and work backwards to find your zero number. That's a way to do it too. I could just do it in my head, which is why I chose to do it that way. All right, if we're given a rule or a graph, sorry, y equals, okay, so in a graph, we typically start with our y-intercept. So that's that 3 number on the y-axis, right? Where does it cross the y-axis? It crosses at 3. That's going to be that last number. It's not the number in front of the x. All right, I need to figure out my growth then. So I'm going to find some lattice points, right? Points that are right on those nice crosshairs for me. Here's another one. I'm going to draw my little growth triangle over here. I'm going up 2 and over 1 if I label it. So my growth is going to be 2. So for my rule, y equals 2x plus 3. Alrighty. Now we are given a rule here. So now for my growth, I know that growth is going to be the number in front of the x, so that's going to be 3. And my y-intercept, or my figure 0 number, is going to be negative 14. I suppose we could do that up here too. So our growth was 2. Our y-intercept was 3. All right, our number of tiles in figure 0. It's the same thing. And then for this guy too, I forgot to write these before. So growth, make sure that you go back and include these. Growth is that number in front of the x, so 5. The y-intercept, or the number of tiles in figure 0, is that plus number, so plus 3. Yeah, you will need these for the homework check, so make sure to do that. All right, last one is our table. So these are in order, so we can see, right, 0, 1, 2, 3, they go in order. That's always the first thing to make sure of. And we're just going to figure out how much are we adding on every time. So I always start at 0 and I figure out from there because I'm going in a positive direction. But I can see I'm declining tiles, so I know my growth is going to be negative. And from 3 to negative 2, right, from 3 to 0 would be 3, and then from 0 to negative 2 would be 2 more, so that equals 5. So my growth is going to be negative 5, right? And my 0 number, my y-intercept, is going to be 3, okay? Because that's right there. All right, well, thank you guys so much for watching and hanging in there. I know it was a long video. Please ask questions if needed. Thanks.